Hi everybody, Brad McCulley here. This is the third episode in a series of 5 that talks about business-based maintenance. If you remember, in the first episode we really talked about business requirements and mapping them to strategy. This is what business-based maintenance is all about. Making sure that my maintenance strategy is aligned with the needs of the business, so I'm focusing on the right things, spending the right money, doing the right things as the business needs them real time, right? We also talked about taking the needs of the business and categorizing them and then going out on the factory floor and talking about which assets are having the biggest impact on the areas that we need to improve. So we spent a little bit of time on that. And we also talked about mapping equipment and failures by name. You think about that equipment on the floor. Even if you don't really have good data and you don't really know how they break, you can go in, you can interview operators, you can do visual inspections, you can talk to the maintenance people, and you can start a list of failure modes and then build countermeasures for those failure modes, right? It doesn't have to be, I have all this data and all this work orders. You know where the problems are. And if you pick the top 5 or 10 failure modes that are the most prevalent, and you eliminate them through PMs, predictive, engineered solutions, operator maintenance, or maybe you choose to run to failure on small failures because you're not worried about it. The cure is worse than the fix, so to speak. But you can get through this. So when we start to put a plan together, how do we pay for it, right? So I'm going to show you a model right now, overall equipment effectiveness. Even if you don't measure OEE, I'm going to show you a model and how you can use it to fund your program to kind of improve it where you're going. So let's talk real quick about OEE. Availability, productivity times quality percent equals OEE. So let me give you a quick example how the math works. So let's say I run a 10-hour shift and I lose an hour. I'm down an hour for the machine failure. That's 90% availability. So I run 9 hours and I'm supposed to run 10 parts an hour. So I should run 90 parts, but I only produce 80 because I've got micro stops, I've got setups, operating problems, whatever. But I don't get them all through, so my productivity is really 89%. And then of the 80 parts I produced, only 72 of them were good, right? So that gives me a 90% quality rating. Now, that's a little bit low. Most of the time manufacturers are a little higher. But these numbers would not be atypical, right? 72% OEE. And my experience has been when I meet with most manufacturers, most plant managers, if they can run at 72%, they're not feeling a lot of pain. So this is what I would say conservative from a math point of view on how you fix things. So just imagine that we build this OEE model and we're going to use it to justify our program. So the plant runs, let's say the plant runs $100 million and you're running 2 shifts, 7 days a week. So 112 hours a week times 50 weeks, 5,600 hours. But because of OEE and because of those losses that we documented, you're only producing $17.8 thousand an hour at the plant level. Now you can use this model at a line level, machine level, whatever you want. I'm just using this as an example to get my point across. But if I was running perfectly with no losses, I'd be running at $24.7 thousand per hour. And you can also, instead of productivity in dollars, I could also do it in units, right? So you think about that, then what happens? So here's what the model looks like. Product velocity measured in this particular case, revenue per hour. If I improve, my baseline was here at 17,000, and I improved 2 percentage points of OEE, availability, which drove OEE, because everything else in this model staying the same, which wouldn't necessarily be true. You can see how the revenue per hour would increase. You're increasing your product velocity, right? So there's a lot of things you can do with product velocity, right? You're eliminating the stop signs out on the factory floor, so product's moving better. Maybe you're working less overtime, your on-time delivery gets better, or you produce more product with the same inputs except for raw material, which means your margin for that additional product is 60–70%. So you think about it, this is what a financial model looks like for a plant that would grow 5% a year, and what would happen is I could improve my on-time delivery, but and just 2 percentage points of improvement of availability could yield $1.5 million worth of bottom line improvements. So this is just one example on how you use the tool, how it all starts to tie together. And now in the future, we're going to talk about the maintenance strategy. So we're back. We started with the business needs. We went to the assets and we said, okay, now we kind of know how they're breaking. We think we know what we have to do, but we're going to have to fund it. Here's a way to document how we fund it. Next, we're going to talk a little bit more about the actual maintenance strategy and things we need to look at and how we measure those. So I hope this was helpful. Feel free to give me a yell at bmccully@advancedtech.com. I hope you enjoyed the video and it brings a little insight to how you can think about maintenance and make sure that you're aligned all the way from customer needs to your maintenance strategy. Thanks again. Have a great day. And feel free to give me a yell on the bottom if you have any questions or comments. Take care.